Hello friends, so I'm here with the first video of page replacement algorithms, and that is least recently used algorithm. So first of all, I'll explain this table. I'm using the same table for all three videos. So these numbers are called the reference string. That means the CPU, it is going to ask page 7 and then page 1, then page 0, 2, 0, 3, likewise. So it is called the reference string. And here these are the frames. So in this example there are 3 frames. So let's start without any delay. In least recently used, what happens is we are replacing a page which is used long ago. That means we are replacing a page which is used first. You will understand it when I am doing the example. So for now, just keep this in mind. So let's start solving. You can see here the first number is 7. This is the page 7. So you can see that these frames are empty. And this page 7, it is not in the main memory. Right? So frames are in the main memory. So if the frames are empty, that means the pages are not in the main memory. So without any problem, we can place this page 7 here. Right? So this page 7 wasn't in the main memory, right? This was not in the main memory. So that was a page fault. In the introduction video, I told you that what is a page fault. So if you missed that video, you can watch it. The link for that video is given in the description. So here the 7 was not here and it was a page fault. Page fault, we can mark it like this using a cross. So now we can place it here. And we are done with this page, so we can come to the next one. It is page 1. So now you can see page 7 is already in the main memory and page 1, it is also not there. See, it is not here. So it is also a page fault. And now we are gonna place this page 1 because there's an empty frame. So without any problem, we can place it here. And we are done with page 1 as well. So now we come to the third page. It is also not in the main memory. So it is a page fault as well. And 7 is there, 1 is there. We are going to place page 0. Now you can see these frames are full. That means now the main memory is full. And now let's come to the next page. It is 2. So here also you can see that page 2 is not in the main memory. So it is also a page fault. And how can we replace this page 2? How can we place this page 2 replacing 1 from these 3? And it is going to be like this. So we are going to replace a page which is used long ago. So this is how you do it. From these 3 pages, you can see that 0 is the one which is used most recently. And 1 it is used before 0. And page 7, it is the one which is used before all these two pages. That means 7 is the page which is used first. So we are going to replace this 7. So we replace this 7 with 2, and this 1 and 0 both remain same. And we are done with 2. So let's go to the next one. It is 0, and you can see that this 0, it is already in the main memory. So is there a page fault? No, right? There are no page faults. So we put a tick here and we write the same, right? And now 3. So you can see there is no 3, and now we have to replace again. So let's see, 0, it is used very recently, and then 1, it is here, and 2, it is here. So you can see from these 3, 2, 1 and 0, 1 is the page which is used first. So we are going to replace this 1 and put 3. So it is 2, 3 and 0. So it was a page fault, right? 3 was not here. Then 0, it is here. So no page faults. We write the same thing, 2, 3, 0. Then 5. 5, it is not there. And let's see what we can replace. 0, it is here. 3, it is here. And 2, it is the page which is used first. So we are going to replace this 2 with 5. And 3, 0, same. And here 2, it is not there, page fault. So from 5, 3 and 0, you can see 3 is the page which is used first. So we are going to replace this 3 with 2, and now 5, 2, 0. Then again 3, it is not here, again a page fault. So let's replace 2, it is here, 5, it is here, and 0. 0 is the least recently used page. So we are going to replace this 0 with 3, 5 and 2 remain the same. Then we are going to 4. There is no 4 here, so it's a page fault. And let's see what can we replace. 3, it is the most recently used page, and then 2 is there, 5 is the least recently used. So we are going to replace 5 with this 4, and 2 and 3 remains same. And then 3, it is already in the main memory, so there are no page faults. So we write the same thing. So here also you can see that there are no page faults because 2 is here. So we can write the same. And here it is 1. So 1, it is not here. So it is a page fault. And now let's see 4, 2 and 3. 2, it is here. 3, it is here. And 4, this is the least recently used page. So we are going to replace this 4 with 1, 2, 2 and 3. Here also 7, it is not here, so it's a page fault. And 1, 2, 3, 1 here, then 2, then 3. So 3 is the least recently used one. So we are going to replace this 3 with 7 and 1, 2. Then 5, it is also not here, so it's a page fault. And then 1, 2 and 7. 7 is the most recently used, then 1, then 2. So 2 must be replaced with 5. And 1 and 7 remains the same. So this is how we solve least recently used page replacement algorithm. So I think you got the pattern to do this. And what happens here is we always replace a page which is used long ago. That means the page which is used first, right? So after completing the table, we are going to find the number of page faults. Page faults. And that is the number of crosses, right? So here 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is the answer. And this number of page faults, it is also known as the miss ratio. Miss ratio. And that is the number of crosses, it is 12, or the number of faults, it should be divided by the total number of pages. So here it is 16, right? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. And then we are going to find the hit ratio. That means the correct number of pages. So here it is 4, and 4 divided by the total count, it is 16. So using the table we can find the hit ratio, miss ratio and the number of page faults. So this is how to do the least recently used page replacement algorithms, and there are 2 more to go, and the links for those videos, they will be given in the description. So let's meet with the next video. Thank you.